Hey guys, welcome back to the channel. Today we'll be solving LeetCode 14, longest common prefix. So we have to write a function to find the longest common prefix string amongst an array of strings. And if there's no common prefix, we just return an empty string. So in this example, we have flower, flow, and flight. And the longest common prefix is FL because they all contain that. In this case, it would be nothing because they're all very distinct words and don't have anything in common. So we can solve this efficiently in O of n times m time and with constant extra space, where n is the length of the longest word and m is the length of the entire array. And this can be solved using a vertical scanning technique, and I'll show you that in the explanation. So the way we're going to solve this is we're going to check the first the first string in the entire array and then compare every element in the first array to every other string or character in all the other strings. So this can be better understood with this example. So we're going to start off by grabbing the first element in this array, which is the first string, and then we're going to check its first character, which is F, and then compare it to all the other characters in this column. That's why we call this vertical scanning, because we're going to compare it to every other character in this column, and every time we see that it is the same character, we're going to add one character to our result. So let's go through this. So first we're here and we check, is the first character F the same to every other characters, and it is. So we can simply take F and add it to our result. Then we're going to move on to our next iteration and check, is this L the same as these two other characters? And we're going to do this with a nested for loop. That's why the time complexity is O of m times n, because there's going to be a nested for loop. And we see that L is also the same across this column. Then we get to this column and we see that this is the same as this is not the same as this, and we're simply going to return our result. And the time complexity of this is going to be O of m times n, where m is going to be the length of our entire array, and n is going to be the longest element or the longest string in our array. And since the only thing we're storing is our result, we're going to have constant extra space. Okay, let's get into the code. So we're going to start off by initializing a result variable to an empty string. And after that, we're going to loop through our first string. So we're going to get the length of our first string and loop through that. So in this case, if our first string was the largest string, we would have to loop through our largest string, and that is why the worst case is m times n. And after we've gone that, we're going to loop through every other string in the strings variable, and we want to have a bounds check here. So we want to check, is I within the bounds? So if we reached the length of s, if I reaches the length of s, we just want to return right there because we obviously can't go any further. Or we want to have another check. If we are in the bounds, we're also going to check, is the current element that we're on, or the current string we're on, is its string the same as our first string's first character, and our first string's current character. And if it is not, we're just going to return result because the rest don't matter because we've reached a case where one of them doesn't, so we don't have to continue. And after we've checked, this entire thing checks our one column, so it checks one vertical column. And if we're all good, we can add to our result the character within that column that they all share. And at the end, we can just return our result. Looks like it worked, and looks like it's pretty efficient. This will run in O of n m times n with constant extra memory. Thanks for watching.